Good morning, students. Today, in this video, we discuss about compiler design, code optimization, how the target codes are optimized. That concept only we discuss today. So, in this particular code optimization techniques, what are the points we are focusing on this today's session? Introduction, classifications of optimization techniques, factors influencing the optimizations, themes behind the optimization technique, and optimization transformations. These are the points we discuss in this video. So, introduction means, we called point how the intermediate code generations and target code is generated from the intermediate code. From this target code, what are the points we need to be reduced the unreachable, unwanted code or additional codes. Everything is possible for the code generation process as maybe appears. So from this code, we are in the position to reduce the size of the code and reduce the number of instructions in the target code. So we need to remove the unwanted characters, unwanted statements, or in position to rearranging the sequence of execution in the given code, whatever it is. So concerned with the machine independent code optimization, machine dependent code optimization having the two different parts. So optimization will be carried out in two different ways, machine dependent and machine independent. So 90 to 110 rules, execution spends on 90% of time, 10% in code. 90 to 10 rule will be focusing on optimization. Their execution 90% of rule to time, it will be based on time, and 10% will be concentrated on code. So it's most moderately is easy to achieve. 90% is the optimization, and very 10% is somewhat difficult. We need to be rectify the particular difficulty into achieve format. So this identification of 10% of code is not possible for a compiler. It's a job for the profiler. So profiler work is nothing but to increase the efficiency. That is our part. In general, loops and what hotspots are somewhat present in the 10% is not possible to achieve. The criterion of the code optimization. What are the criteria we are focusing in the code optimization? Must preserve the semantic equivalence of the program. So we need to be generate the code and we produce the optimized code. It must be satisfies the given source of program. Compulsory equivalent. What is the given source of program? The corresponding program equivalent target code, optimized code only we need to be produced. The algorithm should not be modified. So the given source of program structure, given source of program, meaningful information, everything is not to be modified. The transformation and the average should speed up the execution of the program. So intellectual and compilation efforts spent in inefficient improvements. These are all the points we are focusing on criterion of code optimization. So the optimization is presented in not only the individual, not only for the last phases of the compiler or optimization phase. The code optimization process will be carried out and each and every process. In terms of source code optimization, we are at the time of writing the source code itself, the programmer to analyze and optimize the code. There is the programmer will know about the whether the program line will execute or not. So that particular programmer itself possible to optimize the code. Intermediate code has a possibility in the form of code optimization is applicable. For example, loops, procedure call, address calculation improvements, everything will be calculated in the intermediate code representation itself. This particular process will be carried out in the compiler time. After the code generation, the target code will be generated. That target code also to be utilized the register usage, instruction choice, and peephole optimization process. So organization of the optimizing compiler is focusing on control flow analysis, data flow analysis, and transformations. The code optimizer will be focusing on these 3 points: control flow analysis, data flow analysis, and transformation. The control flow analysis means we can focusing on how the program will be executed by from the flow of the instruction following from top to bottom, top of the program into bottom of the program, and how the data also to be passed from one line to next line. The corresponding transformations will be categorized, will be followed. So the entire process will be called as code optimizer. So classification of code optimization technique is generally we categorize it in 4 ways: peephole optimization, local optimization, global optimization, and loop optimization. These are the 4 different ways we focusing on optimization in corresponding target code. So what are the factors are majorly present or influencing the optimization? First one is the target machine. So machine dependent factors can be parameterized for the compiler for fine tuning process. So the target code is a major important point in the factor influencing the optimization. Second one, architecture of the particular target CPU. Here, number of CPU registers are utilizing the instruction set register RISC or CISC concepts, pipelining architecture, number of functional units involved in the particular architecture, and in terms of machine architecture, cache size and type will be major influencing point, and cache memory or memory transfer technique rate also is important. Themes behind the optimization. So what we focusing on in terms of optimization, what are the key themes we are following is avoid redundancy. What is the meaning of redundancy? Means already computed value is again computed, means there is a concept of redundancy. For example, line number 5 which have the solution A equal to B plus C. That is line number 5. Line number 5 is A equal to B plus C. Line number 10 is also A equal to B plus C. In between line 5 to line 10, B value, C value is never updated or not updated. And A value is also not updated, means at the time of line number 10, A equal to B plus C value computation will be one more time additionally computed, but there is no changes. Line number 5 result, line number 10 result, both are all same. That particular case, we calculate the value again one more time. So that is the concept of redundancy of calculation. So that type of code will be eliminated. That is the concept, avoid redundancy. Smaller code. So based on the priority, the code value will be reduced. Smaller code. For example, what is the multiplication process? Multiplication is nothing but repeated addition. So that in terms of multiplication code, we can reduce it into addition process. That is the concept of smaller code. That work is nothing but less work for CPU, cache, and memory. Less jump. So try to avoid jump operation. Jump operation means jumps interferes between the code prefix concepts. Let's jump. For example, whether the condition is focusing on, for example, conditional jump or unconditional jump. There are 2 different types jumps are available. Suppose we are focusing, we pointed by one condition. Check the condition. If the condition is true, go for the true statement, else false statement. If then else statement. That is also a conditional jump concept. So try to avoid the less jumps in their program coding. That is major work for reducing their optimization. Next, code locality. So code executed closer together in time is generated close together in memory. Increase the locality of the reference. So try to utilize the local variables. Try to involve in the corresponding memory location near to the corresponding memory locations. So everything calculated within a boundary time means it is easily to code locality is very important point. So that will increase the locality of the reference. So corresponding variable, everything will be verified and the reference will be calculated within a boundary time. And extract more information about code. So more information, better code generation. So we give the more number of instructions is possible to generate the code value. Redundancy elimination. So redundancy elimination means determining the two computations are equivalent and eliminate one. So for example, last just before I explain it, line number 5 equal to a plus b plus c, line number 10 equal to a equal to b plus c, both are all same value. So we need to be eliminate the 10th line. So automatically that is the concept of eliminating the one. There are several types of redundancy elimination. First, value numbering, common sub-expression elimination, constant propagation or copy propagation, partial redundancy eliminations. What is the meaning of constant and copy propagation? Constant propagation means we know very well about pi value 3.14. That particular value, whatever the value we will be using, directly the constant value to be utilized means which is a very efficient manner. Suppose pi equal to 3.14 and calculation of area or calculation of circle, area is equal to pi r squared. Pi into r means the pi value again it's stored into the memory. It will the reference will be memory reference will be fetched operation will be performed. After that only the value will be getted. So whenever the program will be executed, the pi value is never changed. So that particular case we can directly store the constant values. Copy propagation means the corresponding variable assigned to pi 3.14 assigned to pi value. The same pi value is again assigned to some other variable. That particular case copy propagation. So that particular level you can directly utilize the corresponding variable means it will be time will be executed. Whereas less directly utilized means execution time will be reduced. That is the concept of copy propagation and constant propagation. Optimization transformations can be categorized in following way. There is also called as principal source of optimization. Compile time evaluation, common sub expression elimination, code motion, strength reduction, dead code elimination, copy propagation, local optimization. Compile time evaluation means during the compile time itself, the evaluations are carried out. So expressions as value can be pre-computed at compile time itself. There are two types, constant folding, constant propagation. At the time of compile time evaluation, constant folding means we know variable about it 22 divided by 7. What is the value? 3.14. Directly we can use the variable value, constant value, directly we can utilize it means that is the concept of constant folding. In terms of constant propagation means we know variable about pi value. Area is equal to pi squared. So area equal directly we can utilize the variable value to corresponding equation means that is the concept of constant propagation. Replace a variable with constant which has been assigned it earlier. The constant values are directly utilizing in their equation. Common sub-expression elimination. Common sub-expression elimination means from this example, identify the common expression present in different locations and different expression and compute once and use the result in all the places. For example, A equal to B into C and some example X is equal to B into C plus Y. So B into C will be value changed, will not change anything. So the value will be calculated, assigned to some variable temp. Now at A equal to temp variable. At the same time, X is equal to B into C, we call as X is equal to temp plus 5. Common sub-expression elimination is a similar point for discuss. Global common sub-expression performed for flow graph which we have implemented. Required available expressions. This is nothing but the procedure. Global common sub-expression elimination performed on flow graph. Requires available expression information. In addition to that, finding what expressions are available at the end point of each basic block. We need to know where each of these expression was most recently evaluated. That is the concept we are focusing on. So that particular level comes here. Next, constant motion, code motion, moving of code from one part of the program to another without modifying their algorithm. That is the concept of code motion. So it's in this particular implementation, optimization technique, which improve the in terms of code, reduce the size of the program and reduce the execution frequency of the code subject to the movement. So in this particular case, the size of the target code will be reduced and execution of the particular expression will be, execution frequency will be reduced. For example, constant posting, if A less than B, then Z equal to X squared, else Y is equal to X squared plus 10. So whatever the condition true or false, X squared value will be computed. So either true time, the value will be calculated, or in case of false, the value will be calculated. So that particular case, that code will be moved behind or before the loop or before the condition. What is the meaning? Then what is the meaning? We calculate the X squared value and assign it to some temporary variable. If the condition is true, the assign to temporary variable, else the value is equal to that particular temporary variable plus 10. That is the concept for implementation. That's constant motion. And next one, execution frequency reduction. Execution frequency reduction. So the code motion, first one is code space reduction. Second one, execution frequency reduction. Reduce execution frequency of partially in the available expression. The similar concept, if the true value will be calculated, Z equal to X squared will be calculated within a loop only, so that Z is equal to, sorry, temp is equal to X into 2, temp is equal, Z is equal to temp, else Y is equal to 10. After that, X squared equal to temp equal to X squared. Next, G equal to temp will be calculated. For next, move expression out of the loop if the evaluation does not change inside the loop. For example, while I less than max minus. So now initially max value will be, we assign it as 10 means, what is the max minus 2? 8. So whatever the condition will be checking, I value less than max minus 2. True statement will be executed. Next, again condition will be checked. I value is increment or decrement. Again, I value less than, again calculation for max minus 2. So that particular time, max minus 2 calculation will be executed whenever the condition will be checked. So that at the time of condition checking, max minus 2 calculation will be repeatedly present. So that will take more amount of time. But that particular max minus 2 value, which is not affect the looping statement, so that we reduce the particular code into the calculation of max minus 2 is previously calculated and assigned some variable t. So now the condition will be lightly changed while I less than t. Max minus 2 value will be assigned to t, so we call as t. That particular time, again a condition will be checked, corresponding loop will be executed. Again condition check, loop will be executed. If the condition is false, control is transferred to outside the loop. So whenever the condition will be checking, the calculation will be based on only the condition check alone, not for further computation process. Code movement, the same point will be again repeated in terms of some other way. Strength reduction. Strength reduction means it's possible to reduce the strength of the code. That means give their equivalent prioritization relationship between their operators. For example, subtraction addition, both are all different. In terms of multiplication is nothing but it is a repeated addition. So compared to these two strengths, which one is lowest strength? Plus or multiplication? Plus is the lowest strength, multiplication is the highest strength. So highest priority is from multiplication, lowest priority is plus. So but multiplication is nothing but it's a repeated addition. So the multiplication process will be replaced to in terms of repeated addition. That particular case is nothing but strength reduction. So typical cases, the strength reductions occurs in address calculation and address references. It supplies the integer expressions involving induction variables. Loop statements alone, the strength reduction is mostly present. Dead code elimination. So dead code elimination is nothing but the problem that particular code never execute at any time or any situation of the program. The dead code of the portion of the program which not be executed in any part of the program, it should be removed. Example, no control flow into the basic block. No control flows into a basic block. A variable is dead at a point. Its value is not used anywhere in the program. The assignment is dead. The assignment assign the value is dead variable. These are some examples. For example, if int I is equal to 0, if I equal to 1, true statement, else false statement. That particular case, whenever the program will be executed, the condition is not true, it's always false. Because before the if statement, the value, the I value is assigned to 0. Here, debug equal to 0 if debug print. Debug value will be assigned 0. So if 0 condition false, automatically the particular statement never to be executed or never to evaluate executed for the print statement. So that particular case, that particular type of code we need to be removed, means automatically the code will be optimized in very effective manner. Copy propagation already discussed. Peephole optimization. Peephole optimization is nothing but it's a small portion of the code will be optimized. Pass over generated code to examine the few instructions, typing 2 to 4 instructions which will be implemented. So there are 4 different types of peephole optimization techniques are there. Redundant instruction elimination, use algebraic identities, flow of control optimization, removal of reduction jumps, use of machine idioms. So redundant instruction elimination. Redundant instruction elimination means at the line number 10, we can change the value R0 value is assigned to A variable. At line number 11, immediately A value is again assigned to R0. So this time, this particular two set of statements, they will does not require the particular coding because this is a redundant immediate changes. First step, change the value R0 to A. Immediately we perform A value to R0. Automatically this two instruction will be redundantly executed, consecutively executed, swapping their variables, swapping their values. So at the line before the line of move R0 comma A, after the line of A move A comma R0, both are all same levels. So that particular can we have to reduce or remove the code. That is a redundant load and store operations are implemented. We need to be eliminated. Algebraic identity. So algebraic identity means, for example, in terms of multiplication identity value will be 1. In terms of addition validity identity will be 0. Division means 1. So that case what we decide, the corresponding computation A into 1 is equal to A. No need for the again multiplication process. Directly you can assign. Next A into 0, anything power anything into 0 is equal to 0. You can directly you can store as 0. Anything divided by 1 is equal to A, anything value. So that particular type of code we need to be reduced. So A into 0 means directly no need for further computation. So automatically directly you can replace 0 value. So that is the concept of algebraic identities. And also strength reduction. A square is nothing but A into A. You can instead of power value, you can utilize A into A. folding jump to jumps, flow of control statements, go to operations. A jump is to an unconditional jump can copy the target address. For example, jump less than label 1. The label 1 also having jump label 2. So that particular time, unwantedly, one jump operation will be present. So we go with line number. For example, if the condition will be checking, go to the address number 100. Again, the control transfer to address number 100. Immediately, it is also passed to address line number 200. Automatically, next our target will be 200. So that particular situation, unwanted switches are there from one particular memory location to another one particular memory location. So that case, we need to be remove that particular type of unwanted jump. If we initially we directly pointed to label 2, jump less than or jump less than means go to label 2 means our answer will be optimized. Jump to return also the same concept. Use of machine idioms. Use of machine idioms in terms of microprocessor code A equal to A plus 1. For example, we need to be calculated A equal to A plus 1. What is the code in terms of machine ordinary code? Move A comma R naught, add A 1 comma R naught. Finally, result R naught value, store the values of A plus 1. Final result will be stored, move A R naught comma A. So finally, A value will be assigned. The value will be incremented. So cost of the instruction will be somewhat 4 or 5. But in terms of corresponding machine idioms, we are replacing. For example, increment operator. So I is equal to I plus 1 here. That means A equal to A plus 1. So increment operator means I and C corresponding variable means automatically the increment value operation will be performed. Simple implementations are implemented. That's all about our optimization technique and various different processes. That's optimization techniques and the people optimization techniques. Thank you. Thank you, students.